All right, this is the end of 4.1. This is where we left off last time. And we had this problem. The bell rang, and we were in the middle of completing this problem. Kind of throws you off a little bit because what it's asking for in the very end is the result. So this says int n is assigned the value of 35. The result is assigned the value of 1. And then there's this n is greater than 0. Is n greater than 0? Yes, 35 is greater than 0. So d is going to be assigned the value of 35 divided by 10, the remainder. The remainder would be 5. So 5 would be d. Then I take the result, which is 1, multiply it by 5, which is 5. Okay? I then take n and divide it by 10 and assign it back to n. So n was 35. 35 divided by 10 is 3.5. But since it's an integer, it would cut off the 0.5 and just give you 3. Does everyone see that? So n would be 3. Is 3 greater than 0? Yes. So d would now be n, which was 5. No. What would we say? 3? 3 divided by 10. What is the remainder? Well, the remainder should be 3 still, right? So 3. What's the result? The result that we had was 5 from the last one, right? 5. I didn't trace it. 5 times 3, which is 15. And then n was, I need to write this down. If I don't write it down, I'm going to go crazy. Which is still 3. It'd be 0. The answer would be 0 with a remainder of 3. Right?
Wait, for the initialization of d or for n divided by 10?
All right, we're starting over. Okay, write this out. So n is 35. Okay, the result is 1. And n is greater than 0. So we're going to go ahead and do the while loop. D is initialized here as n, which is 35. 35 divided by 10. The remainder of that is 5. Okay, so D is going to be 5 there. We then take the result, which is 1, multiply it by D, which is 5. So the result is now going to be 5. Okay. N, which was 35, divided by 10, which is 3.5, and then assign it back. But because it's an integer, 3.5, the 0.5 gets taken off. So n is now just 3. Looping through again. Is 3 greater than 0? Yes. So int d will be 3 divided by 10. 3 divided by 10 is 0 with a remainder of 3. So d is now assigned the value of 3. The result was 5 from the last one. 5 times 3, assigning that back to result. Result is now 15. And n divided by 10, n divided by 10 would be 3 divided by 10, which would be 0.3, right? And then assigning it back. So n is 0.3, but it takes off the 0, or it takes off the decimal and leaves you with 0. Is 0 greater than 0? No. So it prints out the result, which is 15. Whew. It's annoying, right? Unbelievable. Okay. It says, consider the following code segment, which is intended to print out. This is why I like to write things down. I can't do it, even though I teach math, I can't do math very well in my head. I have to write things down. And when people do all this math in their head and don't show their work on problems, I'm like, how do you do that? I never could do that. Consider the following code segment, which is intended to print out the even numbers from 0 to 8, including 8. Okay. It says, which of the following could replace the missing loop header to ensure that the code segment will work as intended to print out the even numbers from 0 to 8. So if count is 0, it's looking for while. While count is less than or equal to 10. Because it's not including 10, right? So 0 to 8. So while the count is, well, let's see here. Yeah, I guess you could do that. Let's try it. That's correct. All right. So while count is less than 10, it would go through. The count starts at 0, but each time it adds 1 to the count. All right. And that's it, 4.1. Questions on 4.1? No. Moving forward, 4.2. All right, for loops. It says, another type of loop in Java is a for loop. This is usually used when you know how many times you want the loop to execute. Okay, so we talked about while loops already. Now we have for loops. In Python, you can write a for loop by for I in, and then you list the range or the list or the dictionary or any other data structure you're working with. It's easier in Python. You would just write for I in, but this is the for loop in Java. Okay, for loops are used when you already know how many times you want the loop to execute, right? If you're not entirely sure, a while loop might be best. For loops, you already have set parameters of how many times that's going to go through. It says it's often called a counter-controlled loop to do the loop body a set number of times. If you took APCSP with a block programming language, we did not. Okay. You probably used a for loop block like below that looks very similar to Java for loops. We didn't use any of those languages. So anyway, this is what a for loop looks like. I'm going to break it down in a few minutes, but basically you have a loop. You initialize the counter, which you start at counting. In this case, the number starts at 1. It's going to continue as long as that number is less than or equal to 5. And after each iteration, it's going to add 1 to the number. So those are 3 parts to the for loop. 1, initializing the counter. 2, setting the loop duration. And 3, incrementing that variable. Notice that there's semicolons after the first one, after the second one, but there's no semicolon after the last one. The semicolons are used like separators inside that for loop, inside the parentheses. Okay? A for loop combines all 3 parts of writing a loop in one line. Isn't that nice? We talked about all 3 parts of the loop, but you can do it all in one line. For loops are awesome. Okay? The 3 parts are separated with semicolons. Each of the 3 parts of a for loop declaration is optional, but the semicolons are not. Okay. It says the for loop is almost a shortcut way to write a while loop with all 3 steps that you need in one line. Okay. So this for loop does the same exact thing as this while loop. look at it. The for loop does the same exact thing as the while loop. You save 2 lines of code in this case. It says watch while they we're going to go ahead and go line by line. So for, notice how we initialize the loop outside the while loop here. We can do that inside the for loop here. While x is greater than 0, that's this right here. Each time we subtracted 1 from that variable, we can do that right here. So it's clean. It's nice. But you have to know the number of times we're going to go through here. It says watch the video.
Okay.
You can watch it on your own time if you would like. It says here's a control flow program for a for loop. It says the code in the initialization area is executed only 1 time before the loop begins. Okay. And the loop continues as long as that condition is true. All right. Here's a for loop that counts from 1 to 5. Can you change it to count from 2 to 10? Well, I can change the initialization of this, initialize the variable 2. We're going to go until it's less than or equal to 10. Change that line in line 5. I ran my code and I get 2 through 10. All right. Here is a while loop that counts from 5 to 10. Run it and see what it does. Okay. Compiling and running your code. So it prints out numbers 5 to 10. Can you change it? Can you change it to a for loop? Run your loop. Does it do the same thing? Okay. So a reminder here, right? This is what a for loop looks like. I'm just going to copy it since we haven't really used it much yet. And I'm going to paste it. And the for loop, the int count, we want it to replicate above, right? So maybe I'll comment out these lines. Okay. So the count starts at 5 and it goes through 10. It then adds 1 to it and then prints it out. Let's run it. It passed. So that's my for loop. The lines I commented out give you the same exact result. Okay. So in only a few lines of code, I was able to write the same thing. A while loop versus a for loop. There's certain uses for each. It says 2 common patterns in for loops are to count from 0 up to an number. That's not right. Maybe they originally wrote integer there and then changed it to number. But 2 common patterns in for loops are to count from 0 up to a number using less than, or count from 1 to the number, including the number using less than or equal to. Remember that if you start using 0, use less than, and if you use 1, use less than or equal to. It says the 2 loops below using these 2 patterns both run 10 times. The variable I for index is used. I is used frequently as a variable for it. Just like how I wrote for I in whatever the list name is. We used for loops already in the tic-tac-toe project this week. That was this week for AP Computer Science Principles, right? So this is a way of writing these loops in Java. Okay. Okay, so you get the same answer for both, right? Both of these give you the same exact result. They both run 10 times. One, you start at 0, and you stop at really 9, which 0 through 9 are 10 iterations. Or starting at 1 and including 10, which gives you 10 iterations as well. All right, what does the following code print out? All right, I is assigned the value of 3. As long as I is less than 8, we're going to add 1 to it after each time. Okay, so I is 3, so it will print out 3. Then it will increment 1 and print out 4. Then it'll increment 1, print out 5, 6, 7. When I is equal to 8, 8 is not less than 8 anymore, so the loop will stop. So the answer is D, 3, 4, 5, 6, 7. Okay. It's not A because 8 is not less than 8. What does the following code print out? It says I is assigned 1 as long as I is less than or equal to 10. Run it and then add 1 each time. So we'll print out 1. It's inclusive of 10. So 1 through 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It includes 10, so it can't be B. It also starts at 1. Answer is C. God bless you. How many times does the following method print an asterisk? It says I is assigned 3. It's going to run as long as I is less than or equal to 3, and then we'll add 1 to it each time, right? As long as it's less than or equal to 9. So 3, 4, 5, 6, 7, 8, 9. I counted 7 on my fingers. C, check it out. It is correct, right? 3, 4, 5, 6, 7, 8, 9. That's 7 times. It says the following method has the correct code, print out all. The code is mixed up. Do you guys see anything?
Yeah.
You do?
Yeah, it's like the typical drag and blocks, but instead it's like you have to arrange it where the indentation is right.
Wait, what is this? It gave me like. Look at this. You guys have that?
Yeah.
Wow.
Yeah, the indentation is important here. It's weird because they never emphasize indentation.
Guess I'll come back to that. Like, help me. I don't know what's going on. You guys have it, and I don't. That's weird. All right, well, do that. I'm not sure why mine's not showing up. Maybe I can let me log out and log back in. Maybe. Let's see. CSAwesome. Log in. All right. All right. Well, mine still doesn't show. I'm not sure why. I'm just going to move on. Well, thanks for letting me know yours shows. Mine doesn't. So I guess I'll just fail the class, right? You can count backwards as well. You can increment loops, but you can also count backwards. Let me cast my screen so you can see it. There you go. You can also count backwards. It says from the last number and counting down to 0 or 1. Here's an example of that. It says, what do you think will happen when you run the code below? How would it change if you changed line 11 to initialize i's value to 3? So let's look at it. Okay. String, bottles of pop on the wall. Line 2, bottles of pop. Line 3, take one down and pass it around. Loop 5 times, 5, 4, 3, 2, 1. Okay. As long as I is greater than 0. So it prints out, it should start at 5 and it should say 5 bottles of pop on the wall, 5 bottles of pop, take one down, pass it around, and it has 5 minus 1, so that would give you 4 bottles, bottles of pop. So I guess what it's asking is, what do you think will happen when you run the code below? Well, let's run it. All right. So now it's asking me, it says, how would it change if you changed line 11 to initialize i's value to 3? Well, that would just have a lower starting point. Okay. So change i's value in line 11 to 3. All right. The method print pop song prints the words to a song. It initializes the value of the variable I equal to 5, and then it checks if I is greater than 0. Since 5 is greater than 0, the body of the loop executes, blah, blah, blah. The next one, it says, can you make the loop count by 2s backwards? It should print out 5, 3, 1. Remember to change all 3 parts of the for loop. Okay, so we're starting at 5. We're going to go as long as count is less than or equal to 1. And instead of adding 1 each time, we're going to be subtracting 2, right? Let's run it. Oh, doesn't like that. Right. So I guess I can a way around this is maybe didn't like that I did that inside of there. As long as it's greater than or equal to 1. Good call. As long as count is greater than or equal to 1, it never ends up running, right? Because it says, is 5 less than or equal to 1? No, and it just, right, doesn't end up working out. There you go. Silly mistake. Okay, so we changed it. Line 5 is what we changed. We start at 5. As long as the count is greater than or equal to 1, we're going to subtract 2 from it each time. So subtract 2, assign it back to count. All right, back to using turtles. I remember, I think it was Greg or Logan or someone, they said, wouldn't it be easier if we just looped it? It's like, yeah, it would be a lot easier, right? Now we're to loops. Now we can loop it. It says, do you remember when we used the turtle objects to draw shapes? Okay, we drew a bunch of shapes. We drew a house, right? To create a square without loops, we had to repeat the code over and over and over again. It says, can you change the code below to remove the repeated lines of code and use a loop to draw 4 sides of the square? So look at that code. Okay. So let's write a loop. I can say for, and we'll say I'll assign it the value of 0, right, into I. And it will run as long as I is less than 4. And each time we're going to add 1 to it. I can then delete 6 lines of code here. And then close my loop. Okay. Let's see if I messed up. Look at that. Lazy programmers are the best programmers, right? Like, I don't want to do all that work. I don't have to type that out. Let's just write a loop, right? Smart. Some people call it lazy. It's smart. That's what it is. So that was the code we wrote. You could have also wrote it like this. Watch this. Right? That would run 4 times, right? That would run 4 times. But the way that I always, like the way that I learned it was, hey, however many times you want it to end at, it just helps you remember, hey, I want it to end at 4. Okay, if I'm starting at 0, it runs through. An APCSP, on the APCSP exam, indexes start at 1 instead of 0, which make no sense. Sorry, College Board, but what's that? On the APCSP exam, loops start at 1, or sorry, index starts at 1 instead of 0. It's very weird. They thought it'd be easier that way. It's easier. Yet confusing. It says, we create a for loop, whatever. Have Yertle draw an equilateral triangle. Oh, I remember that. Remember this from a few years ago when I did this. It was a pain because I was trying to do math in my head and didn't write it out. Okay. It says, have Yertle draw an equilateral triangle using a loop. How many times should the loop run? Well, if you're drawing an equilateral triangle, it should run 3 times, right? Remember that it ran 4 times for a square. So how many for a triangle? My 3-year-old son can answer that question, right? What angle should you use for the turns? So if I had 360 degrees divided by 3, what does that give you? 120. That's my Algebra 2 student, right? 90 would be divided by 4, but 120. It says, have Yertle draw a pentagon using a loop. Okay, so first, let's draw a triangle, right? An equilateral triangle. Add your loop here. Okay, so I'll say for initialize int I, assign it to 0. As long as I is less than 3, and each time we'll add 1 to it. My curly braces open, my curly braces close. Take this and put it there. Okay, that should give me an equilateral triangle, right? 120, 120 if I move 100. Let's run it. Let's see my equilateral triangle. There's a triangle. I wish it was like that way a little bit, right? But that is an equilateral triangle. Technically, that does solve that. Okay. Then it says, have Uridal draw a pentagon using a loop. A pentagon has 5 sides. What's 360 divided by 5? 72. 360 divided, 360 divided by 5. 360 divided by 5.
360 divided by 5.
Yeah.
72.
There you go. See.
So
Yeah. See, there you go.
that's Chinese.
That's Chinese. Oh man, Wells. Smart man.
Yeah, it's not Chinese.
You have to memorize that. Uridal. We're going to go ahead and make our pentagon. Maybe we like pick the pen up. We'll say Uridal dot move or Uridal dot pen up. One up. Pen up. And then we'll say Uridal dot move to 100, 200, maybe do 300, 300, 200. Try that. And I'll say Uridal dot pen down. Make sure to put a semicolon there. And then I'll loop through 5 times. It'll move forward 100. But then we turn 72 degrees. All right. So my loop goes through 5 times. 4 loops. Let's run it. Oh no, I went off the page. Wow, that's ugly. So maybe I'll move forward 50.
It's like a pentagon.
Trying to draw a pentagon. All right, let's do 50 and see what happens. What didn't it like?
Oh, it should only have forward one. Like you can't do most, you can only do one at a time.
I can only do one at a time.
Because the error is like the error.
It's saying 1 forward, 2 forwards. That's silly. All right, well, there's my pentagon. I'll have to comment out. I'll just comment out these lines of code, right? Comment out this line. It didn't like that I drew multiple shapes. There's my nice pentagon over there. All right, what's the last thing it wants me to do? Create a variable n that holds the number of sides for any polygon, and use n in your loop for the sides and to calculate the angle to turn. Can you have the loop draw a variety of shapes by just changing the value of the variable n? This is very smart. Comment out all that code. Okay, so I'll create a variable. I'll say n is equal to 9. Int n is assigned the value of 9. Then say for, I'll just copy my loop from over here. Okay. So for I is assigned 0, right? As long as I is less than 3, we'll say as long as I is less than n. Okay. But now we have to play with the number of sides, okay, and the turn that it would be. So it would be, we came up with turn 360 divided by n, right? That's what we came up with before, because it was like 360 degrees divided by 3 gave me 120, right? 360 degrees divided by 5 gave me 72. So 360 degrees divided by n should give me the right one. Let's test it out. Does anyone know what a 9-sided shape's called? Nonagon. Smart man. All right, so I had 360 divided by n there. So let's say I wouldn't have to keep on writing these loops. I could just say, all right, let's draw instead of a 9-sided shape, all you change is one number, right? This is what I'm talking about with smart, concise code. If your boss says, oh, by the way, remember that triangle you drew last week? I need it to be 16-sided. You're like, oh, really? All you'd have to do is type in 16 there, right? So a hexagon, right, has 6 sides. If I type in n, make sure it's outside the loop. You see a hexagon. And there's a hexagon. All right. So what did I do? Have a variable that I had outside of the for loop, and that will automatically show me the number of sides. Okay, I know that I want to loop through the exact number, right? Whatever that was, 6 sides. And the way I have the correct turn is I take 360 and divide it by the number of sides. Done. It says 4.2.5 summary. There are 3 parts in a for loop header: the initialization, the test condition, a Boolean expression, and increment or decrement statement to change the loop variable. Okay. A for loop can be written as an equivalent to a while loop and vice versa. There's just certain times to use each. The more you use them, the better you get at them, and the more you realize what each of them are for. AP practice. Consider the following code segment. It has count 0 and a sum 0. While count is less than or equal to 6, add 1 to it. Divide that number by 2. Or sorry, if that number is evenly divisible by 2, then add it to the sum. Okay. So it should give me 2, 4, and 6. 2, 4, and 6. You add those up, and that gives me 12. So the sum should be 12. Which of the following code segments will produce the same output? Okay. So we know the answer is going to be 12. So we're going to have to run through 3 of these and see which one the answer is. All right, so I have count plus plus. If if count, so I've added 1 to it. 1 divided by 2, sorry, is 1 evenly divisible by 2? No, so that doesn't run. Okay. Then it goes again. Is 2 evenly divisible by 2? Yes. So that should run. Let's see what's different between those two. It looks like these two are exactly the same. Only this is using a for loop, right? So we know 1 is one of the answers. So it's either 1, 1, 2, or 3. Let's try this one. Okay, this one gives me sum is assigned the value of 0. 4, I have my loop here. I print it out. This does not give me the same answer because it doesn't test and see if it's evenly divisible. Well, no, because, okay, let me look at this. Sorry. 0 is, it would include 0, it would include 2, it would include 4, and would include 6, right, as it loops through. So I guess it would work. 2 works as well. Let's look at 3. It says for j is assigned the value of 7. Is 7 greater than 1? Yes. So that counts down all the way, including that. So that one looks like that one works as well. 1, 2, and 3. Let me check, make sure. Oh, nope, I was wrong. It says note that 1 has an extra count at the beginning of the loop that should be deleted. Ah, I see. So the for loop, it caught me, right? There's already an increment right here, and then this increments it again, right? So that should not be there. So the answer should be 2 and 3 only. Yeah. I got thrown off by that one. I missed that. So you already are incrementing it right here. You don't need to increment it again there. All right. 2 and 3. Says consider the following code segment. Int result is 1. It says I is assigned the value of 3. As long as I is less than 6, it's going to move through, and it's going to add 2 to it each time. So the result is going to be 1 times 3. So result is now 3. I now add 2 to it. So I is 5. And then so result is whatever we had 3, right? Sorry, this is why I don't do math in my head. I'm doing it all over again. Sorry, guys. I'm trying to do, it's simple math, but I just can't do math in my head. My brain's just getting old. All right, so if I have I is assigned 3, as long as I is less than 6, the result is 1. 1 times 3, the result is now 3. Okay. Then the second time through, we've added 2 to it. So 5 is I. Okay. The result was 3. 3 times 5, result becomes 15. Okay. And then I is 5. So, or sorry, we're adding 2 to it now. So it's no longer able to run past there. It says, which of the following best explains how changing the for loop header to for I is assigned 4, I is less than or equal to 6, I plus or equals 2 affects the output of the code segment? let's see the potential. If I is assigned 4, it would run through twice still. So the output of the code segment will be unchanged. Is that true? No, I don't believe that's true. So I'd say the output would be different. And then, but for both versions, the loop will iterate 2 times. Let's try C. Yeah, there we go. So the output will be different, but it still loops through 2 times.
Why is it looking two times?
Because you say 4, and then you add 2 to it is 6.
Or equal to I.
Yeah, and it's inclusive of it. What's up?
Leave my water in here.
There you go.
Thank you.
Yep, no problem. Even though it wouldn't let me do the mixed up code segment part, it says I've completed 13 of 13 activities on this page. So completed, well done.
Can we go back to the Pentagon real quick?
The Pentagon. Okay, question.
So mine is saying that it's false when it calculates angle correctly using n.
Bring it over here. Let me see. So you've signed 6 because you're starting at 1. But okay, but
No, I thought
450.
0 and then,
Oh, your turn each time has to be different.
okay.
Your turn
Also,
has
it's
to
a
be
variable.
360 divided by n.
Okay.
All right, that's what should be the problem. All right, moving on. 4-3. We're going to see how much we can get through. Definitely not all of it, right? So once you're able to learn conditionals and loops, right, a whole world of different possibilities opens up. And you can look back at things we previously learned and think, oh, you know what? I could maybe do this an easier way. Okay, I could do this in a way that might end up being more efficient. So it says in 4.3, it says loops and strings. Loops are often used for string traversals or string processing, where the code steps through a string character by character. Okay. You also see it in Python. They call it lists, but arrays in Java. It says in lessons 2.6 and 2.7, we learned how to use string objects and built-in string methods to process strings. In this lesson, we will write our own loops to process strings. So it says, remember that strings are a sequence of characters where each character is at a position or index starting at 0, right? So in this string, this is a test. 0 index is the capital T all the way to the lowercase t at the end, which is 13 index. Okay. The first character in a Java string is at index 0, and the last character is always whatever the length is. So it'd be 14 characters minus 1 because we start counting at 0. Okay. Just to review what we covered in 2.7, there was the length method, which determines the length of a string. The index of method, which returned the index of the first occurrence of that string. And then we have the substring, which returns a certain starting index to end index, any characters that are inside of that. And then a substring from just, it says return the substring from to the length of it as well. Yeah, so if you just add one argument in there, it will just take you from that point to the end. So the same actual method, just different parameters. Different number of arguments that are submitted. 4.3.1, while, find, and replace loop. Okay, so a while loop can be used with the string index of method to find certain characters in a string and process them, usually using the substring method. So it says, I have the string, and I've called the string S, and I've given it the value of example, all lowercase. It says I start my loop with 0 and says, notice I'm using a while loop because you can use this for really any word. You don't know how many characters are going to be in every single word that you use. So you'd probably use a while loop instead of a for loop here. It says the index of A, right? If it's greater than or equal to 0, right? Loop through, and it's going to find and save the next index for A. And then from there, we'll tell you the letter that it is. The example in the mixed up code below, it actually gave me this one. Finds and removes all the letter A's in a string. Why don't you just put them next to each other, right? Why do they do this? All right. Oh, they did. Look at that. They put it next to me this time. Next to each other. Okay, so start your main method, end your main method. I'm going to have my string, which says, are apples tasty without an A? And then I'm going to start at index 0. I'm going to print out the original string plus, which concatenates the original string there. I print it out. And then I'm going to start my loop. So I'm going to go ahead and open up my loop there. So it says while there is an A inside of the string. I'm also going to close my loop so I don't forget to. We want to remove the A at the index by concatenating it. And I guess it wants me to find the index first, right? So find the index of the A. Then we're going to remove the A by concatenating the index. And then finally, once all that's done, the loop will go through and end. And then we're going to print out the string with A's has been removed. Okay, so that's what my code looks like. My main method, my string, initializing my index at 0. My while loop initializes here. Going through and finding the next index for A, and then moving on, ending the loop, and printing it out. It says Google has been scanning old books and then using software to read the scanned text. The software can get things mixed up like numbers 1 and I. I can see why that might be a mistake. The following code loops through a string replacing all the 1s with I's. Trace through the code below with a partner and explain how it works on the given message. Going to run it. Have a long and happy life. But there should be L's, not 1s, right? It says change the message to have more mistakes with 1s to test it. Have a long and happy, maybe I'll put 2 1s here. Is that what they wanted? Yeah. So they want me to mess up the string even more. So I put in a 1 for the I there. We walk through it. So basically, we look for 1s and then print out found a 1 at the specific index for each time. And then add that substring and creating a new string each time. Okay. All right, I'm gonna go ahead and stop here. We've gone through a lot today. I think this is a reasonable place to stop. We'll pick up at 4.3.2 starting next class.